So the period is 2 pi. The absolute max of y is 1, negative 1. The absolute max of x is positive infinity, and the minimum is negative infinity.
Isn't it 1 and negative 1? Oh, no, for x, never mind.
Yeah. And then the amplitude is,
Wait, what?
the amplitude is, because they put max first and min second. I don't know why that's backwards.
No, I thought it was talking about the x value, where the maximum and minimum occurs.
There is no maximum and minimum x value. It goes on and on forever. The y value has a maximum and minimum.
Oh.
Notice it says y equals here, and I don't know why it says domain. Domain is all real numbers, or negative infinity to positive. The range is negative 1 to 1.
Absolute max at.
Yeah. But there is no absolute max. It's just infinity and negative infinity. And then it has zeros. Sine has zeros at 0, pi, and 2 pi. But they continue on and on and on forever. So what we do is we write this as x equals n pi plus pi. So x equals n pi x equals n pi, where n is an element of I'm going to go with this one. There are a couple of different ways to write integers. A lot of places use this, like the fancy R. This is a fancy Z. It means all the integers. So negative 1, negative 2, negative 3, 0, 1, 2, 3, all of those. So you can write it as x equals n times pi. When n is 0, you're at 0. When n is 1, you're at pi. When n is 2, you're at 2 pi. And so on. So that takes care of all of them. Intervals where the graph is positive. All right, we're not going to try to list all of them, but we will list negative 2 pi to negative pi and 0 to pi. All right, it's positive. Oops. It's positive when it's above 0. So it's positive here. And it's positive here. Right? And then it's negative in the other. So it's negative from negative pi to 0 and pi to 2 pi. Now, that continues on and on and on as well, but we're just going to write the ones you can see right now. Okay, so any questions about these? So for my cosine graph, cosine starts at 1. Here's pi over 2. Like this. So, whoops. Okay. So it froze. So the period is still 2 pi. The absolute max is still 1 and minimum is negative 1. This is still infinity. and negative infinity. The domain is still all real numbers. The range is still negative 1 to 1. The amplitude is still 1. Now the zeros are on a different pattern. The zeros are at n times pi over 2 plus pi, where n is an element of the integers. The intervals where it's positive is negative pi over 2 to pi over 2. And 3 pi over 2. Well, if we're just going to do this part, it would be 3 pi over 2. Because they happen every pi units. So if n is 0, did I do it right? If n is 0, no, I didn't do it right. It's when n is 0, it's going to be pi, and that isn't right. I didn't do it right. Thank you for asking. It is.
So if you just remove the plus pi, you'd be right, just n times pi divided by 2.
All right, so that would be 1. That would be 2 times pi over 2. No, it wouldn't be time. It'd be plus. It starts at pi over 2.
The first 0 is, pi over 2. And then you add.
And you add pi to get to 3 pi over 2.
So isn't it just pi over 2 plus pi n?
Does that works? Pi over 2 plus n pi. So n, yeah, that's right. The n goes on the pi instead of the pi over 2. Yep. Thank you. Because you're adding no pi, and it's pi over 2. You're adding 1 pi, and it's 3 pi over 2. You're adding negative 1 pi, and it's negative 3 pi over 2, and so on. Still, n is an element of the integers.
The zeros of sine are just pi n, and cosine is just pi over 2 plus.
Yep.
Right? So
Yes, because it's just shifted, pi over 2 plus pi n. Yes. And then it's negative between negative 3 pi over 2 and negative pi over 2 union with pi over 2 to 3 pi over 2. Okay, any other questions about that? Oh, I didn't finish this one. This is 5 pi over 2.
So why is the domain all real numbers?
Because it is a sine wave, it never ends. Have you studied waves in some of your science classes? Sound waves, and they never end.
So that's the shape sound waves?
This is the shape of the sine wave. Sound waves will have a different frequency, but we'll talk about things like that when we get into the real world problems. When we change the period and the amplitude, then it's a different frequency, and so they're sinusoidal. Sound waves are sinusoidal. So, in particular, this is the parent function for sine waves. So the sine wave is in red. Everywhere the sine wave is 0, 1 over 0 is undefined, so those are the asymptotes. The cosecant is the reciprocal of sine, so this is 1 over sine. Cosecant is 1 over sine. So you take those curves and you flip them out, and then they have to stay within the asymptotes, and that's cosecant.
Pi over 2 but does it intersect at those points? Because I thought it was an empty hole.
No, it does intersect at those points. Because 1 over 1 is still 1, 1 over negative 1 is still 1. When you take the reciprocal of those values, it's still that value. And then the expression is pi over 2 plus n pi, where n is an element of the integers. That's where all these intersections are. Here, here, there, and there. That's where all the intersections are. So any questions about cosecant? Yes. The comparisons below it are homework as well.
So homework is all of the graphs or
All the comparisons. We're going to do tangent and cotangent together as soon as we do secant for the graphs, because I didn't have an animation for you for that one. So we're going to do those together. All right, so any other questions about cosecant? So we're going to graph cosine in red and then secant in blue. So cosine starts at 1. Oh, I'm off. Remember that these are semicircles. They're not. Yes.
I don't think they're perfect semicircles, because if you graph it, it looks like this.
Well,
It sort of stops.
yeah, they're on the circle here, but then they have to take off and go to the next one. But they're not parabolas. They're not U-shaped.
I guess you can graph these parts first and then just connect them.
Which that's what I usually try to do, is just make it round and then Okay, did you understand what Alavi said? They aren't perfectly semicircles, or they would go right back up to the x-axis. But these parts right here are semicircles. They're not U-shaped. They're not narrow like a parabola. They're around the circle. If you drew the circles in here, they would only touch for the part right at the max of the min. Does that make sense? Okay, so this is cosine. Now we want to draw secant in blue. Based on what you saw about cosecant, what do you think is going to happen? The asymptotes are going to be where cosine is 0, right? So we everywhere, whoops, that's not right. Everywhere that cosine is 0, those are our asymptotes. What?
We found that it's actually a 7-degree function.
I googled it and then I found this.
At least it is on one.
It's no higher.
Yeah. So it matches for a while. That's pretty interesting. Oops, I left my mouse. Okay, so go ahead and finish drawing in secant.
Did everyone just steal my markers? I don't like markers on me.
No.
Go ahead and draw. Why is it back to this and not that? Why did it lose? So the intersections are at x equals n pi, where n is an element of the integers. So the red ones are tangent. The blue ones are cotangent. They're shifted and reflected, one of the other. And the intersections are at x equals pi over 4 plus n times pi over 2, where n is an element of the integers. Is that right? Do I have it right, Alavi?
I don't know. Yeah, I guess so.
Because they're pi over 2 units apart, so I'm multiplying by n, pi over 2 units to get them to repeat. And then they start at pi over 4. Those are the intersections.
Where do you put the n first?
Why do I put what first?
The n instead of putting it, on top or at the right.
I don't know. It's a convention. If you see it in the textbook, it'll be written that way. I don't know if we have an actual reason.
Because I thought you have the constant first.
Normally you do, but sometimes when we have, like if we have a square root, we don't put the square root's really the constant, but we don't put it in the front either. So it's just, I can ask if there's a real rule. I just know that it's a convention to do it that way. Okay, so I cleaned that up a bit. So the blue is the cotangent, the red is the tangent, and the repeating is this symbol. Now, your assignment, again, is to complete the comparison that's at the bottom of these graphs. And you're going to have about 20 minutes to work on it now, but I have one more thing that I want to talk to you about that's an assignment for you and something that I've changed for this semester. So we'll talk about that now.